thank you very much for coming to this event on the BCS London branches, North London, Central London, and South London. We three branches have grouped together to form the London branches community. And this is a meeting of the London branches community. Well, that sounds like a big title, as it were, but as you can see here, we've been doing lots of events and producing videos. So we record the events and we've got them all stacked away so you can look at them afterwards. So last year, we did 44 events. This is a list of them, flashing by your eyes. Well, they flashed by ours, so you may as well share it. Share in that. We did 44 events last year on various topics, and we categorized the topics into different, what do we call them? Initiatives. And if we go to the second of these documents there. So, for example, one of the initiatives was on AI. And here are some examples of the AI initiative events that we had last year in 2023. So if you go next. By some great speakers. One of them, Kitty, is right here. And so those are some of the AI events that we did last year. And AI is advancing, of course. Our first AI-related event wasn't called that at all. It was in 2020, and it was called automated learning or something along those lines. Because as you know, machine automation was where a lot of AI ideas began. And so AI has evolved very quickly indeed because of, particularly of ChatGPT. But today we continue that trend, and the initiative on AI with the lecture we're going to have today, which is about conversational AI. Now, what is that? Well, I don't know. Marcus, you were looking this up. What did it say?
Absolutely. So Google tells me that conversational AI is a type of artificial intelligence that can simulate human conversation. It is made possible by natural language processing, which is a field of AI that allows computers to understand and process human language. And shameless plug here, Google's foundational models power new generative AI capabilities.
Wow. Well, so now I know.
Say AI speech.
Yes. So now I know, and so do you. But I think two chaps here have got a slightly different spin on things. And as AI spreads into lots of different subtopics and attaches itself to lots and lots of different categories of our world, we will see lots more of this evolution of AI. So today is about using large language models for purposeful AI conversations in the enterprise. Now, what are they? Marcus, don't bother, it's okay. We'll find out in a few minutes. There are two chaps here who are going to tell us much more about it. One of them is Professor Mark Woodman, and the other is Philip Greenwood. And they are in a company called Ipseita. Okay, good. So Mark,
Hello, everybody, and thank you very much for coming. Stanley just introduced me. My name is Mark Woodman. I'm one of the presenters tonight, although having said that, I'm going to say very little, which for anybody who knows me is quite a sacrifice. Mostly my colleague and co-founder of Ipseita, Philip Greenwood, will be taking you through our ideas. I'll be sitting at the back with David trying to field questions that come in online. For those people who are online, please send your questions through, and I'll join back in the Q&A afterwards. I'll give you a quick potted history of our company. and our backgrounds. So you've got some measure by which to interpret what we say and make judgments about what we say. So Philip has a background in engineering and international consulting, has worked in all kinds of sectors, including supply chain, healthcare, the oil industry, retail, and so on. I'm an emeritus professor now of IT. I have a background in basically systems design and software engineering are my backgrounds. We formed Ipseita 7 years ago with some might call us futurists, but we don't simply theorize, we don't simply study what's going on, although we do that. We build solutions for our customers and therefore test the ideas out as they're coming along. And part of what you'll hear tonight is coming from that work. There are a couple of sort of sub-brands, Digital Acumen, which is you'll hear a little bit about tonight, which are our ideas on how leaders really need to put digital first in their decision making for good decision making in the future. There is nothing that we really do in today's world that isn't based to some extent on digital technology. So we've got to look at those ideas first. Ipseita Labs is the division, if you like, that actually does the R&D and does the work, and you'll be hearing about that during this evening. Should mention that some of the work that you'll hear about tonight was enabled by, or accelerated probably by, a grant that we won from Innovate UK last year. It was on conversational AI assurance. Now we probably won't go into the assurance part of that so much tonight, but we'll be happy to talk about that later if anybody wants to follow that up either in Q&A or afterwards over the frequency that we'll enjoy later on. So if I go on to the next slide, and I'm going to call on Philip to explain this, or explain himself even in creating this artwork in the background. But this is kind of representing some of our ideas about what we call digital first and technosocial sense making. Now that's not a phrase that you probably won't have heard unless you've done one of our courses. It's our approach to how leaders in particular fill gaps where they cannot know sufficiently about the detail of technology, particularly emerging ideas in technology. We started by focusing on blockchain and AI. AI more generally than generative AI, which is so dominant in conversations at the moment, if I can use that word. So I'm going to hand that over to Philip, and he can justify that diagram, and I'll join you again later on.
Whenever I fail. So, well, we've got a packed hour or so today, and I wanted to start really with the big picture. If you go to my LinkedIn profile, you'll find I describe myself first of all as a technosocial sense maker, and we realized we were using the term technosocial instead of socio-technical. Well, that's interesting. Why are we doing that? Oh, we're thinking about the profound impact that technology has on society, not just technology inventions, but actually the increasing capabilities of technology, the development of capabilities of technology through time. And we have a very long history here of it. In fact, when you started studying history when you were yay high, they used to talk about the Stone Age and the Bronze Age and those technologies. And after a while, they stopped talking about the ages and they started talking about kings and queens. And somehow that didn't jive so well for me as an explanatory narrative. So I've sort of created a list of technologies that I feel that have had profound effects on the way we organize ourselves as society. And I think that we haven't included, say, the stone axe there. I think there are a few that have had more profound effects than the invention of the Stone Age, than the stone axe. But as you can see, since we're going to talk about AI, well, actually, it's been around a while, since the mid-20th century, when the term was originally coined. So it's been through quite a long history. And during that time, there have been a few other fairly big developments that probably have enabled it, have made it as powerful as it is currently. And then, of course, last on this list, we've got advances in AI that we've seen recently. So the artificial neural network type of AI. And I've picked out a few salient dates in the last 20 years there. 2006, when deep networks were postulated by Jeff Hinton and his team up at University of Toronto. 2012, what we will call the AlexNet moment, when convolutional neural networks and parallel computing won the ImageNet Prize. 2017, the publication of the paper Attention is All You Need by Google, and the sharing of the idea of transformers. And 2022, I think, is also going to go down in history with the release of GPT-3, or in fact, a particular version of GPT-3, Text Da Vinci 002, when it suddenly seemed to become competent and useful and interesting. And that was a moment when, fortunately, we had our hands on it already. And it was that, oh my goodness, this has changed something. This is exciting. So I would say those dates are there and worth thinking about from our perspective. So I wanted to start with the big picture thing. We're going to range in terms of scale today. So I'm going to be talking a bit about different types of AI. I'm going to be also demonstrating some somewhat prototype software. So if it all works today, it'll be an absolute miracle. And I'll obviously never demonstrate your technology live in front of an audience. So we'll break that rule. I'm also sharing my full screen, not windows. Hopefully nothing embarrassing is going to happen in the background. So that's another cardinal sin, the presentation that I'm going to break. I'll probably stumble, I'll probably flub, but it's nice to see some familiar faces in the audience. I've been to a few of these and I do recognize a few people around. So your generous support and thoughts will be much appreciated. Okay, so I think this is another idea that has driven our thinking about technological change, which is, you may have seen presentations by Ray Kurzweil, who talks about the faster than exponential fall in computing costs and draws a graph that goes up like this. I talk about the collapsing cost of compute. And this does really seem to be driving things, because the graph that he draws shows that we have reached parity with the human brain. So is it a surprise now that we have machines that appear to be thinking? I don't think it is. Calculations are a fundamental economic input. The lower the cost, the more things we do with them. There's some slightly flaky maths, I think, that goes into his calculations, but we're sort of emulating this. But the point is that as he plots this, it's actually a faster than exponential rise, because this is a logarithmic scale. Faster than exponential is an incredibly fast rate of development. So if we're now at parity, well, we can expect some things to emerge now, such as superhuman computation, superhuman AI, coming very soon. I think that the effects of cheapness is well described in this book, Prediction Machines. Now, take note of the name of that. This is a book about AI from a few years ago, 3 years ago, I think. And it's obviously talking about a previous era of AI as we look now at it. But the points that it makes about the economic side of computation are very important. The first, of course, is the cheaper something becomes, the more we use of it. And the cheaper something becomes, we substitute other things with it. And a third effect is the things associated with it, and complements, rise in value. So the value of data rises in value. The data rises in value because computer price drops and cost of computation drops. So we can expect for the services to be provided everywhere. Now, Prediction Machines is a very interesting title, because what they cottoned onto was what AIs were doing essentially is prediction. So hold on to that idea, because we hear a lot of people talking about AI at the moment, and they don't seem to differentiate between one form of AI and another form of AI. And that frustrates me, because it indicates they don't really know what they're talking about. You know, they come up, talk about AI ethics and the threat of AI, but they just put it all in the one bucket. So I'm going to take that frustration and exercise a little bit today and actually show some of the different types of AI and how they're different before we get into the conversational piece. But we'll get there fairly fast, I hope. While I'm on the subject of technology driving change, there are other big things going on in the world that we shouldn't take our eye off. So if you're thinking about technosocial change, I've just cited a few of the biggies here. We've got in the developed economies, we've got, well, tapering demographics. We've never had that before in history. We never talk about it in politics. We never talk about it in economics. If you go to an economics section of a bookstore and look in macroeconomics or economics textbooks, you'll never find mention of demographics. I think that's weird. We have relentlessly increasing carbon dioxide in our atmosphere, seemingly despite anything we do. And we've been trying to do this for decades, haven't we? We've been trying to address it, but no, it's still going upwards and it's still accelerating upwards. So what's going on there? And we also have potentially, plausibly, a post-capitalist society. It could be said that after 800 years of interest rate decline, what we saw in 2008 with the banking crisis was almost inevitable. What does that mean? Interest is the cost of money. It's the value of money. And so if it hit zero, that was an interesting moment. Have we recovered from it? Possibly. Do you think when we moved from the feudal age into the industrial age, people knew at the time that they'd moved? We don't really see it in hindsight, but perhaps we have. So, okay, that's a little aside. I've been using this slide for a few years. As you can see, it's a little out of date. It's not got anything beyond 2020 on it. I call this mistake the long, long history of AI, but I also, this slide, the long, long history of AI, I also call it my big mistake. And I know it's too detailed to read from most places. Actually, in our courses, we animate it and zoom in on the various things and discuss them, but I'm not going to do that here. What I'm going to do is hand wave about this orange line. That's my big mistake. So it was observed that AI had gone through winters and summers. So it had funding, and then it didn't have funding, it had funding crises. And what was going on? AI wasn't delivering. It had been this magical thing that hadn't arrived so many times. And it was observed that the AI winters were perhaps the times when the money was flowing to the human-computer interface, and that they were having summers. And so, well, we see this squiggly line going on where AI had funding, had developments, people had been excited, and then it died off, and there was some excitement around the time when I graduated, and it died off. I was really interested in it back then. I did my dissertation at Cambridge on expert systems. I think it was 90. And I've kept my eye on AI ever since, and occasionally tried to use it, tried to deploy it to things. But I thought this was going to be the end of the summers and winters, the end of the cycles. And so I drew this upwards. What's the big mistake in that? Well, as you'll see towards the end of this, actually, I think what's happening is the two fields are converging. The human-computer interface and the AI are actually converging. Now we've got compute power and the training data to do it. So let's have another quick think about that. This isn't going to be a rigorous explanation. Maybe there are people in the room that can actually correct me on some of these things, but I'm trying to get something across. Just get a little bit deeper than the superficial narrative you hear about AI in the papers and the popular press. I think there are three major types of AI that we have at the moment. Now, there are some exotics as well. So the three major types are supervised learning, unsupervised learning, reinforcement learning. There are some exotics as well, things like evolutionary algorithms, Bayesian drafts, symbolic AI, and so forth. But I wouldn't say they died off. They're still in use in places, but most of the discussion is about these three groups. The AI we've seen over the last 20 years, mostly talked about up until 2-3 years, has been supervised learning. And so a very loose description of that is learn by example. So you have some data and it's labeled, and you throw lots of examples at your AI model, and it gradually learns. seen all this data, I can now predict what the answers are to that. So it might be predicting whether you've got a hot dog or not a hot dog, or looking for anomalies, or credit scoring, or fraud detection, or property price estimation. These are two types of techniques called classification and regression. And the quick way to think about that is with the next slide. Classification is where you're trying to draw a border between different classes of data. So is it hexagons or circles? And regression is, what's my value? What's my tendency within that? Is there a line or a curve that I estimate for new data? So that's been kind of the stock up until when? We saw a few exciting things coming from Google DeepMind, didn't we? So it learned to play Go and learned to play chess and shogi and AlphaZero. So it learned from self-play with no priors. That was kind of learned from experience or trial and error type AI. So that's reinforcement learning. That's, again, not the subject. Very interesting stuff, but it's kind of slightly fallen into the background at the moment because the narrative around chat and conversational AI. Yeah, we've seen that. Challenges are for it. Requires a very careful selection of the reward function, so it learns well. Typically requires a digital environment to do the training in because the real world is very, very slow and expensive. In the digital environment, you can do lots of parallel learning and so forth. So I think we'll probably see more of that coming in the future, but it might well be layered on top of other kinds of AI. And this was almost sort of infamous from the high number of project failures. It used to be, if the project said it was going to be using reinforcement learning, you could fail. And it was only seemed to be DeepMind that actually got them to succeed. So I'm going to flip back into the middle of this table now, because that's really what we're talking about this evening. We're talking about unsupervised or it's been recently rebranded to semi-supervised learning. Now, here we're not looking for lots of labeled data. So if you've got an objection about using AI and something, you're going to need a lot of labeled data for that. Where are you going to get your data from? Well, actually, because the language models we're using are pre-trained, actually somebody else has found the data. And it learned from itself. It learned to predict on itself. So unsupervised learning's very useful for doing things like cluster detection. So if you've got some data and it's sort of clustered in various dimensions, and you want to show me if there are 5 clusters here, what falls into which cluster. I've got a new data point, which cluster does it fall into? So that's been a majority use case, or K nearest neighbors is often one of the algorithms that's used in that. Majority use case, but association rules for data mining, dimensionality reduction. So if you've got a lot of different parameters to go into a prediction, you want to reduce the amount of dimensionality to reduce the compute, you can use unsupervised learning for that. And another one that most people usually forgot to mention was you can use it for compression, which, by the way, is what these are. Yeah, our word embeddings for large language models are really an unsupervised learning technique for compression. So this is learn by reflection or perhaps sense making, because and that perhaps is random descriptions for what it's doing, but I think they're reasonable given the results that we're seeing. So yeah, famous for large language models, famous for market basket analysis, famous for customer segmentation. But they do, in fact, have very high compute costs. And they also do require lots of data, although in the case of unsupervised learning, it doesn't have to be labeled. So all of these AI models have something in common. So I call this kind of a decoder ring slide. And as I've tried to get it all compacted onto one slide, it has got a little bit complex. But basically, the point of this slide is to emphasize that these are mathematical models. They're dealing with numbers. This is not magic, although sometimes it seems like magic. It's not magic. These are parametric statistical models. in the middle there. And on, the input side, they need to take in numbers, and those numbers could indicate continuous, variables, or they could indicate discrete variables, but they're numbers. So the data comes in, we do feature engineering. We used to do a lot more feature engineering, and in fact, what deep learning was, hey, let's just look at the data. Let's not worry about trying to convert those pixels into how long's the tail on the animal I'm looking at, and giving it the number of the length of the tail. Let's just let it look at the picture. We'll use some more parameters, we'll do some more compute, we'll use some more data. But that effectively is what deep learning did. We'll say, okay, we're going to do much less feature engineering. We throw that into a model, we adjust the parameters to optimize either for some goal or to minimize some loss function. So there's a training loop here, we get an output or an error loss, and that helps us adjust the parameters. And on the output, we get, again, numerical outputs. And sometimes we do the reverse of the featured engineering to actually get the results we want. Same thing's happening with large language models. It's just the same thing. Now, often I hear people talk about the algorithm. There's more to AI than the algorithm, right? There's the data, there's the training, there's the hyperparameters, the settings that the way you set up the model. And there are typically two algorithms. One is learning how to predict. On the right, we're doing either inference or prediction, and they're very similar. Inferences are all around what's now, and predictions around what's next. So learn how to predict, that's one algorithm, and then predict or infer, that's the other one. And I like to use the terms machine learning and artificial intelligence differently than most people. When I'm learning how to predict, I think that's machines learning. Yeah. And when I'm doing prediction and inference, I think that's artificial intelligence. Now, for a time, we called it machine learning. I suspect that was because that's kind of all we did with it. We seemed to be always training and not getting results out of it. So it seemed to fit at the time. But let's allow ourselves to perhaps use those terms a bit more, apply the English as opposed to the jargon. So as we look at these large language models, what are they doing? Well, the first thing they do actually is feature engineering. So although we live in the era of deep learning, we take language and we turn it into numbers. We do it by taking the words and tokenizing them. Various strategies for doing it. There are 3 of them. Word-based tokenization to split it the spaces. ChatGPT is great, exclamation point. Suburbs. So we've got a chat in there. Oh, yes, and we got G and we got PT. Or we could do it the character-based. In fact, if you've been using the GPTs from OpenAI, they do sub-word tokenization. So whenever you think you're putting in a word, it probably sees it. It might see if it's a short one, it'll see it as one word. If it's a long one, it'll break it up into fragments. So the first thing we do is take the words and turn them into numbers so that we can actually process them in our AI mathematical models. The next thing we do is we take that information and try and find a vector for it. So we have called an embedding space. Actually, I'm going to show this in 2 dimensions. Why? Because it's easy to show on a flat screen. But actually, the embedding space of a language model might be 100 dimensions. I don't know exactly how many it is. I've seen papers suggesting that about the right threshold is 110, 120 dimensions of embedding space. So you're trying to find a vector with 100 numbers, potentially. And what you're trying to do is as you're looking at sequences of text, you're trying to identify where to take that token, but not just the token, but this has not come out properly. The token in the context of other tokens that precede it. And you're trying to predict what the next token is. And so what you're doing is you're saying, I've got this token in context. I'm trying to find where it fits in the embedding space such that all my losses are minimized. And in doing so, you end up with something that says the words, let's just go back to words rather than tokens, and let's not do tokens in context, but the words can be dealt with mathematically. So for example, if you take king, subtract man and add woman, you get queen. And that does actually work. Yeah. It can be done mathematically. So now, okay, so you're taking the internet and you're compressing it down into 100 trillion parameters in 100-dimension embedding space. Something magical happens. It really shouldn't. It really should. It should be impossible. But the big surprise was it worked. And that's what we're talking about today. So is it magic? I don't know. But even OpenAI said, you know, we were pursuing this direction of reasoning. It was interesting. We'd seen indications of success, but we were still surprised when it worked. And I can quite understand that sentiment. So what have they ingested? Well, actually, it's enormous. I think this graphic was from maybe a year and a half ago. So it does talk about various models that have been developed to date and what they'd ingested. And yeah, they've done web common crawl, and there's actually a big database to support doing that now. But it had ingested all of Reddit, it had ingested lots of academic journals, it had ingested books, it had ingested Wikipedia, it had ingested GitHub, Stack Overflow, and increasingly they're trying to create synthetic data because actually one of the bottlenecks of developing the next generation of LLMs is where do you get all the new data from? I think they're also trying to ingest rich media such as video. They're happy to also throw images at it so that in a way they're no longer language models if you're looking at images as well, but still seems to work. So what we have perhaps is a general purpose embedding space model moving forward. But this is a vast amount of data, but it's still going into 100 trillion, approximately 100 trillion parameters in 100 dimensions. So it's compression. As you encode that into the values of those parameters, it's actually a compression algorithm. And it's lossy. It's not a perfect recall. And this is one of the concerns, of course, that we have with it is that you know, sometimes people call it hallucination. I prefer the term confabulation. But it can seem awfully confident about erroneous answers. So how good is this? These are some results for 3 LLMs. And I'm not wildly familiar with this particular slide, so I'm going to read it with you. But this is ChatGPT 3.5 is the green bar. GPT-4 is the black bar, and Google's Bard, which has now been renamed Exodus, no, Gemini, is in the blue. And these are performances on the question bank for neurosurgery oral boards examination preparation. So neurosurgery. Who'd have thought LLMs would be able to answer questions on neurosurgery? And yet we see, in general, we've got GPT-4 getting 80% correct. In functional stuff, it's actually 85-ish%, and about peripheral nerves, it's 75%, and goodness me, what's that? On the spine, it's 90%. I mean, that's astounding performance on neurosurgery. A year and a half ago, I built a chat tool, and we beat OpenAI to the punch by about 4 months on this. We've been playing with GPT-3 and thought, oh, let's get some memory. And I showed my mother, who's a microbiologist. I said, ask me a question about microbiology, because I've got no idea if the answers are right or not. I said, let's ask you a question about microbiology. And I sat down, she said, okay. And of course, came up with an answer, and she sat there and, how the hell does it know that? Oh, wow, we're really onto something there. They're great, but they have issues. They are, after all, statistical models of knowledge bases. They're not knowledge bases themselves. They are expensive to update, run into the millions. The estimate for GPT-3, I think, was 12 million. I'm quite sure that GPT-4 was multiple times that. And they can produce socially and ethically unacceptable results. So there are things that we can do to fix this, and I want to go through some of those today. I prefer to look at it this way. This is a diagram drawn from cognitive neurology that talks about the capabilities that we recruit to do thinking. And I put some marks against the various boxes and lightly modified it to suit my own perspective. The bit that I've modified is this practical plausibility. They use the term common sense, which I think is nonsense. I don't know what it means. It seems always to me to be used in a passive-aggressive way, so I wanted to get rid of the term. What I think they mean is, is it plausibly practical? And so I've renamed that. So what are they good at? Well, clearly they're very good at language, language understanding and generation. They have very broad general knowledge, for sure. Those two, I think, are self-evident. They're not very good with practical plausibility. They can often make mistakes from that. It's interesting to me that the more specialist your knowledge base becomes, if you ask it about that, you'll go, no, that's just wrong. This is made up. And that was emphasized to me by my cousin, who asked it a question about tennis. Now, he plays royal tennis, court tennis, and they call it tennis, for heaven's sake. I mean, maybe it was the original one, but he asked a question about the chase. Who's heard of chase in real tennis? Real tennis. It's called tennis. No, I don't know what it is either. But anyway, I thought, well, that's an interesting challenge now, isn't it? Can we educate these things on the subject of real tennis such that it can answer plausibly to that? But clearly it was very comical that it didn't know what a chase was in real tennis when he called it tennis. Corin, if you're on the call, sorry, mate. Are they good at formal reasoning? My experience of working with young ones is they give every appearance of reasoning, being able to reason over facts and come up with responses. But actually, lab tests of formal indicate that they're not so good at it, which I think leaves a question mark. The question mark is, actually for me, is how much formal reasoning do we actually do ourselves? Or do we have this illusion that we are rational, reasoning beings? Actually, we just sort of kind of vaguely feel our way through life most of the time. I think that's more likely. Another thing LLMs don't have is metacognition. They don't self-monitor and they don't do orchestration. And that, of course, for a conversation is all essential, isn't it? So what can be done about that? And they're also not good at sort of planning. So they're not looking ahead and trying to achieve particular results. They tend not to keep episodic memory. Actually, that's quite easy to fix. We got that fixed 1.5 years ago. And then there's situational understanding. Situational understanding is geographic spatial. And we haven't even tried to address that one yet. I've not seen the results for it. Now, before we get into the demo, how's my timing? I wanted to just reflect. So that's what we're trying to address. We're trying to get ticked for each of those boxes. We have a technology called the chatbot, which we've been using for maybe a decade. And some of them are even called AI chatbots. And we have a skill called conversation design that is applied to use those chatbots. So how is this different? Well, first of all, chatbots tend to be just decision trees. And what you're doing in the chat is trying to get somebody to go through a finite number of choices at any given point. And they might indicate those choices by a menu or a form. or they might indicate their choice is actually in natural language and type something in, and then you do a little bit of natural language understanding on that and hope it fits in one of your three categories. That's a classification task. Yeah, so it's there, but most of the time, these things have. You look at this is actually from a marketing agency that develops chatbots. It's an Australian one, and it's actually only half of the diagram, twice this size. But I was amused by these are the prompts that they wrote, for each of these stages and the options that you had to go through, and so forth. And every one of them, except one, ended up with this: "Thank you. I will have somebody from the team get in touch with you ASAP. It was nice to chat with you. Have a great day." This one said, "Happy house hunting. Have a great day." So you can guess what the domain was. So it seemed like the best we could get from chatbots was just delivering you to the right person to respond to you outside of the time that you actually wanted to address the subject. So there's clearly an opportunity there to do something better. And the same thing happens, I think, with voice technology. So, as larger organizations, we set up contact centers, don't we? So contact centers for interacting with the public, contact centers for the IT help desk, contact centers for HR, even for a very large organization. Some organizations with many suppliers have contact centers for their suppliers. So this field of contact has lots of different technologies in it, and this may well fit in that type of space. These aren't going to go away. I mean, they're certainly useful in some contexts. They've been successful in some contexts as well. I wouldn't sort of dismiss the work that's been done on them. It's just very interesting to see another form of chatbot, which is, "Oh, I'm going to go and chat, and there's somebody sat on the other end, which, oh, nobody here at the moment, we'll get back to you as soon as possible." Or if you're lucky, you get through to somebody and they're juggling 4 different conversations and you're waiting for 3 minutes between each interaction. Not great. So given what we've seen, you might expect a conversation to be, user on one end, AI model on the other, in the middle, interactions, yeah? But come on, you ChatGPT, and you're driving the conversation. It's good at answering questions most of the time. It's good at creating content for you if you ask for it most of the time. But it's got no agenda. It's not driving the conversation anywhere. That you have to bring to it, which isn't a conversation. It's a chat. So we've got to ask some questions. The flow of purposeful conversations is in the title of the talk, is Purposeful AI Conversations. What kinds of conversations could this be? And we use this to represent, customer-led discussion lasting 2 hours about the merits of a service being considered for purchase, or a bicycle, could we represent a conversation like this between a student and an academic team about learning outcomes, syllabus content, deadlines, and so forth over the course of a couple of years? Awesome. Can we represent it like that? Is that reasonable? I suspect it's not, but it's interesting to me how well it maps to what I'm going to show you. So conversations, though, are powerful, and we do an awful lot of them. They're not mere chats. They have structure. They often are trying to drive towards high value, but they flow and they recur on themselves, and things that people have said get forgotten, and they reify, they're clarified, the purpose is clarified over the course of a conversation. And then people, the two interlocutors bring information to each other, they share. And because of that, there's an architecture we've got to build to be able to support AI conversation, purposeful AI conversations for the enterprise. It needs to be able to deal with the individual, like goals. It needs to be robust. It needs to be scalable. It needs to be assurable, because, of course, we care the brand image, and that's not wrong. It's probably going to need to incorporate a diversity of AI models, because just the one LLM isn't going to get you there. And it also is going to need to be able to allow the expression and use of logic, because that's what you should be able to go through, and it'll run on premise and on cloud. Something, you know, a bit more like that: rich, complex, contingent, self-evaluating, with a plan, aligned to goals, brand assured. So that's what we've been developing or prototyping. Something with enterprise-grade architecture, something that allows the incorporation of different AIs doing different things and trying to work in concert. This is where I demonstrate. So give me a moment to switch screens. This is a design of a conversation, not that one, that one. Yeah. For a, it's going to play hard to get as well. There it is. This is the design of a conversation agent that we have to do career counseling. And one of our earlier models. And what we did was we said, okay, how do we assess the progress of that conversation? How do we design that conversation? And we used a set of language models and other AI tools to put it together. We built it into this, this tool that allowed us to rapidly prototype and evaluate the results. And as you can see, if you go into these different components, we can structure the flow of the conversation this way. There's a set of dynamic prompting techniques that we use to generate the language in context and do progressive evaluation whilst aligning to a goal. The principle we used to do this was a thing called decision quality. And it's a management science, it's a decision science. And we realized that actually what we were doing with a career counselor was we were trying to get somebody to come through to a decision that they were happy with and wanted to take action on. And so we looked at that and said, well, how do we get there? So can we segment the flow of a conversation into a set of activities, set of discussions that brings somebody towards that outcome? So I'm talking now not from a technology delivery perspective, I'm talking to you now from a conversation design perspective. There's a certain amount of prompt engineering going on here, not prompting, there's actual real engineering goes into the prompt design for each of these stages. One of the things that we decided was to use a strength-based approach. So we used the Clifton Strengths Finder. So there's a set of 34 different strengths that the Strengths Finder identifies. And the suggestion that Clifton Strengths Finder makes is you should do a career that plays to your strengths because you'll be happier and you'll perform better in it. So we then looked at, well, how do we evaluate what somebody's strengths are? Well, it's probably things they enjoy doing. And it's probably things that they're already interested in achieving. So maybe we should actually go through that conversation, have that, in order to elicit what their strengths are. And based on those strengths, then make suggestions about alternative careers. So let's demonstrate. This is, we decided that we wanted to not too much deal with the front end, so we've used Slack. So this is integrated with our company Slack, and this is my account. So hopefully there's nothing too embarrassing in this one. Now I'm going to use a little prompt here called RefPE. So this helps me develop. One of the things we haven't overcome or haven't addressed is if you're in a multi-party conversation on something like a chat client, like our corporate chat client, when does the AI respond? Every time somebody puts something in, or only when called upon, or when it thinks it's got an answer that really adds to the conversation? We haven't engineered that yet. It's an interesting challenge. So I'm using RefPE. Ref just calls on Kaya, the coach, and PE says, I want to use the career counselor. Why PE? I don't remember why PE, but there it is. Hi there. Now, I blew the database away before we started, so it's going to treat me as a stranger. And I've also included a little bit of feedback. That tells me it's worked, it's received the message. And in a moment, it's going to give me a response it wouldn't normally give, but for the purpose of the demonstration, I think it's quite interesting. It actually looks and evaluates things like sentiment. And what's our status? How's our relationship? Have we just started? Where are we in the process of doing the counselling? Hi, I'm doing well. Thank you for asking. I hope you're having a good day too. I'm here to help with your career planning. Great. Our approach, now I haven't scripted any of this. I've told it how to behave, but I haven't given it the scripts. Our approach is to build an understanding of the strengths, interests, aspirations, which help us identify your potential career path. Okay, how's that sound to you? Yeah, pretty good. Okay. Again, it's received my message. It's brief in comparison to the coach, but that's fine. Again, it's going to say, well, it's probably just reached the criteria to pass through the preliminaries because I've said, yeah, I like that approach. What do we do next? So it's going to start going in and saying, well, there we go. It says exploring the approach. Relationship state known. I'm now known. I was a stranger earlier on. What's my sentiment? Well, polarity is positive, subjectivity neutral, intensity moderate, valence pleasant. We chose to keep the number of dimensions of sentiment down but it guides it on how to respond. I'm glad to hear you consider the approach productive. Good. The next step is for us to identify an open and inquisitive discussion. I can zoom this in, can't I? Well, that's what Mark's signal was all about. To ensure on the same page, my approach includes interest exploration, strengths assessment, aspiration clarification, career alignment. Does that sound to you? Yeah, I want to go ahead with that. Okay. Yes. Let's go ahead with that. I'd like to use astrology as well. Oh, should we give it a challenge? Oh, you're right. Yeah, absolutely. Thank you. Ref PE. Wouldn't work without it. But that's just code.
Astrology isn't
Sorry.
I know. I thought I'd give it a challenge and see if it could actually deal with it. Remember, it's tokens in context.
Yeah.
And so, subject intensity, moderate, valence, pleasant, somewhat subjective, positive. We're into assessing strengths. Okay, great. Moving forward with our conversation. I appreciate your openness to discussing various angles, including an astrological perspective. Astronomical. That would have been interesting. Well, while I focus on more conventional career coaching methods, I understand exploring personal traits through different lenses can provide additional insight. Okay, quite tolerant. We're probably still going to astrology is with my expertise. Let's proceed by delving into your strengths. Okay, what energizes me? Oh, I love to sail. I love to sail, and I love science, like astrology. So, as you can see, we are in the section of that conversational flow that's about strengths elicitation. And I can then say, I can ask direct questions. What do you think my strengths are, perhaps? Conversational status suggests, well, gosh, we were suggesting careers already. That was quick. Maybe my conversation design needs a little work. I probably should have spent a little longer time on that. But actually, I've spent 2 months having a conversation with this chatbot. It reckons I've got a great future in AI ethics. I told it, no, I'm ethically void. I don't know what it means. I've got no idea what the term is. It says that's a good place to start. you see what's going on here. I think the demonstration's sort of done it, and we can entertain ourselves with this as well, but actually you can also have a serious conversation and go through this process quite well. So I think what we've seen there, to go back to our map, is we've addressed some things here. We've addressed metacognition, self-monitoring orchestration. We've addressed planning, and you've clearly seen episodic memory going. Okay. Now, why have I called these? These used to be crosses. I've made them as question mark. The question mark, why? Until it's really proven through extensive usage, I can't say whether I've done a good job there. Have we done a good job? I think so. It feels like it's something. The orchestration of the use of LLMs using additional AIs to do those tasks has achieved something more than you get by using ChatGPT. How am I doing on time?
25 minutes.
Good. Okay. So I think we need to address some other things. This specialist knowledge one, and this is a very lively topic of conversation in the AI and LLM space at the moment. Is how do we get past this hallucination piece? And the field is calling itself retrieval augmented generation, or RAG, and that requires you to be able to incorporate. So if you're using this in a corporation, in some enterprise, you probably also have systems of record. If you're interacting with a customer, it might be around their previous purchases or their preferences. If you're interacting with an employee, it might be about their employment record and so forth. You need somehow to be able to refer to those within the conversation. So we have this technique called retrieval augmented generation. There are really three ways to modify the way that the conversation works with an LLM. One is pre-training. That's very expensive. You need to be somewhere, with the resources of Salesforce or Microsoft or Google to be able to do that and pre-train your own LLM. You're in the millions for doing. You can also do fine-tuning, where you're taking a pre-trained model and you're doing a little bit of extra training based on your own data to get it to respond in different ways. And then the third way is inference, at inference time. So that's when you're running it. You can give it additional information in the prompt that it sees that the user doesn't see. And it will then process on that information. It'll reason across that information. I hope it's reasoning. Feels like it's reasoning. I also use it, by the way, for coding, and I'm so impressed with the amount of complexity I can throw at the LLM and get reasoned responses out of it. I have to say, I do believe somehow the embedding of those techniques in that high-dimensional space means that the LLMs have learned some form of ontology, some sort of knowledge about the world and some way of reasoning. And we have, if you look at a biological correlate to it, there's nothing in our brains that sort of indicates that we don't have reasoning mechanisms. We do have neural networks, so it emerges in our brains as well. So why shouldn't it emerge in these machine brains? So actually, from the perspective of being adaptable, the retrieval augmented generation at inference time is probably the most flexible, most useful one. And the process kind of looks a bit like this. Now, oh gosh, that's moved. And I wasn't quite sure where to draw that particular line as well. But so the user makes an input. That input is then evaluated by the LLM. So there's some kind of context evaluation. It looks at that and makes some decisions about what resources do I need to marshal to respond to this, context, to respond to this prompt. What it then does is generates queries that it can run against different kinds of databases or knowledge bases. That query very often can be submitted to corporate systems of record and knowledge bases that are secured, so only the relevant information can be transferred back out of them for this context. We then consolidate that in with the prompt that we've seen from before. We then generate a response based on the composite. And that composite then is, of course, referring to the specialist knowledge or the systems of record knowledge that goes in. So it occurred to me that we should have a good look into the whole knowledge base piece. And it really seems like we've got two approaches that are prevailing, one of which is vector databases. Now, this is very similar to the technology that we used with the embeddings. You take the prompt, we'll go back a slide again. So in the context of evaluation, you generate a query that you then match against vectorized content. And that vectorized content, of course, is created by the embedding space as well. So we're using very similar technology. In fact, that we can use the same embedding space to vectorize content as we can use to generate responses. So that's one. And given it's taking such a rudimentary approach, you basically can take the knowledge documents, chunk them up somewhat indiscriminately, throw them against the embedding tool, get your vectors out, and then do searches against it, and actually get good responses in terms of being able to add specialist knowledge. It's surprising and promising, but it's not easy to verify what's going on because all you've got is a database full of strings of numbers, and it's quite hard to maintain if you want to fix it, if you want to change it. The other approach, of course, is the knowledge graph, which you might look at and say, well, that's a very, very manual process. How do we do that? The nice thing about a knowledge graph is because it's full of associations, you can take knowledge content and then you can find things that are related to that knowledge content and get a better quality of response out of the knowledge graph than you can out of the vector databases. So we looked at this and we said, well, what could you have best of both worlds? Could you use both a knowledge graph and a vector and use vector databases in that? And sure enough, Neo4j started offering that capability. So we thought, well, that's interesting, but what about getting the data in there into a structured knowledge graph from our documents? So, well, we thought, well, hold on, we've got some pretty fancy tools here, haven't we? We've got some AIs that we can use. Let's see if we can use them. And here's demo number 2. Now, I'm going to give you a little bit of glimpse behind the veil on this one, but I'm going to go back to our platform. This brings me back to real tennis. I pressed my cousin to give me a copy of the rules of real tennis, and where are they? I have them here just to show you, but actually it would be worth looking at because you can see the form of document before it goes in. I think they're on the desktop. The laws of tennis, not real tennis, not royal tennis, not court tennis, tennis. This is, I'm sure they do that just to, it's written like a contract. It's actually quite nicely indexed. It defines its terms, paragraphs and number. This is quite a structured document. So, maybe we've been given a leg up on that one. And we wanted to see if we could actually generate a knowledge graph using LLMs from a document. So now this is a batch process. You're not doing this in real time. This is about building a knowledge base. So let's do it. I am going to quickly show you my database is empty. Right? So this is the magic button that deletes everything in it. I've already deleted 109 nodes here. Look, this is what my knowledge base looks like, empty. Okay, let's go back in and do some processing. And not you, where are we? Ingest. I'm going to let it run for 10 minutes. We have time. So submit that. This is right up to where we've got to develop at the moment, but I'm going to show you the live output as it occurs. And here we go. You might seem a little familiar. We just looked at the document. That's the front page, the laws of tennis. revised 2012, so it's much less up to date than we are. And I've given it some instructions. I've used some prompting. Consider the text to elicit entities and relationships about the game, such as laws, rules, terminology, play sequences, participants, court, equipment of this form of tennis. Always finish the output. Never produce partial responses. Process headings, paragraphs, sentences, and lists, but ignore things that look like tables of content and indexes. So I've given it also a template there of what the output should look like. So this is a kind of query called a cipher query that's used on the Neo4j database for building knowledge graphs. I've said don't create merge so that I don't lose things or overwrite things. And there it is. It's from the first page, it's produced just the one entity, laws of tennis. The laws of tennis were revised in 2012. So I've asked it to create entities and relationships and give summaries of what they're about and names. Okay, it's unfortunately it's going through. Here's another one. This one's done some relationships as well as some entities, and we're on to the third and some of the text. So actually, if I go here now, you might see that my knowledge graph is beginning to build. So yes, it's slow. It's still a bit prototypey. But we have in there, we have summaries of bits of knowledge and entities and relationships and the way that we can process over and we can elicit information from. We can build that into our prompts, you know, having evaluated the necessity to do this loop in the first place using another AI. So the whole piece starts to feel like an orchestration task rather than building sort of bigger and faster and larger AIs. It seems to me as we've got here something that is a tool that can actually imminently be deployed. I don't think it's quite there yet. It's still working on text, for example. So that worked a little faster than I expected, so I'm really quite pleased. It's not without errors. Sometimes I get errors on the cipher. I'm going to have to do a bit more sort of hygiene on what it returns. And the next step is to take those summaries and vectorize them so I can search against them and pull out content and related content as well. Okay. Stop that process. After 10 minutes, it times out. It's the platform we built takes care of errors as well. Yeah. Right. Go back to our map. Have we dealt with the specialist knowledge one? That should be blue. Maybe. I think this shows promise. So our map's starting to look like it's being covered in the areas where it's useful. I very rarely run into this issue of practical plausibility, i.e. common sense. And I very rarely run into situational understanding. I'm sure there are some contexts of using it. Somebody suggested, oh, I'm going to use an LLM to drive a treasure hunt. I'm thinking, yeah, it's not going to know the spatial relationships between places in the town you're doing the treasure hunt in. But nevertheless, he's pushed it out as an app and seems very happy with it. So there's that. So, no, the reason it's not blue, we're still on question mark for specialist knowledge, but we've at least addressed it. Okay. So do we need to wait for artificial superintelligence or artificial general intelligence when we have those tools that so appear to be working? I don't think we do. I think the current we have the tools in the current state of the art to be able to address conversational AI for the enterprise with orchestration. And that's the big insight that we've sort of got from the work we've been doing with our tool, Kaya. But even if we don't, the rate of progress is dramatically fast. This is GPT 3.5 versus GPT-4, which is the green, over a panel of different examinations of a diverse range of subjects. And as you can see, in less than a year, it was profoundly better in many of them. And there's no reason to believe that, things are going to move backwards or things aren't going to continue on, particularly given the amount of investment. This is another old graph. It was from September. OpenAI is the one on the left with 14 billion of equity funding, Databricks, Anthropic. What's missing off this? Google, Tesla, what's the Chinese ones? And anything that actually isn't, AI 21 Labs isn't American, it's Israeli. But basically, this is a very orthodox-centric view. But there's clearly a lot of money going into building these AIs, these LLMs are, and we want to be able to continue to use them. The key here is, who's it working for? The orchestration, it can be working for you to your ends, to support your brand values, to support your enterprise and deliver value to the people it's interacting with. Okay, so how big's the opportunity? It's actually vast. We did a bit of a think about how do you categorize conversations, and if you can come up with a few dimensions of different types of conversations, how many of them would there be, and then where should you apply that? And the ones we came up with were high value intentionality. This is what we call purposeful conversations, and there are two types of those, we think. One of them is where you're heading towards either the changes or the creation of some form of contract. And that might be an interpersonal contract rather than a legal contract, but very often you're going through a conversation with somebody in an enterprise. There's a contractual term that covers a decision that you make on that call. And then there's the nurturing conversations, the tutors, the coaches, the mentors, and that kind of thing. But these all have high value intentionality. They deal with complicated or complex domains. These are not simple domains, they're complex. They very often have high personalization requirements. And some of them have high emotionality. Now, is it reasonable to use an AI to do a bereavement conversation at a bank? Probably not. Although I've noticed that some people are actually at times more comfortable talking with an AI than another human. And in fact, that was something we observed way back in the 70s with Liza. It was a very rudimentary chatbot. And people were saying, can you leave the room? I want to talk to Liza, because I had a conversation. So why have I got red and I got blue? So first of all, A and B. These types of conversations are commercial and personal conversations. The stakes are high. So this could be about financial planning. It could be about inheritance planning. It could be about healthcare. I mean, those are interesting levels of conversations that you could be having. The blue ones are the less emotional ones. Commercial conversations. These could be about supply chain issues. It could be about procurement. They could be about strategic or functional aspects, and they have low emotional impact. The dividing line here for the red and the blue, we feel, is avatars. These, perhaps the blue category, can be dealt with through text, or perhaps through speech. But often those kinds of conversations, you want to sort of record the change that you have. So let's have a quick look at the state of the art around avatars. This was from a blog, the Lex Friedman blog with what's his name, Mark Zuckerberg, and they were demonstrating in this Meta's metaverse. And if you look carefully, you can see just a little bit less detail on Zuck than you can on Lex. So I think the camera was, this was the local, and I think that was the remote. And this was done with goggles. But the thing that caught our eye about this was the rendering was in real time. So we've seen some, human-like avatars tend to fall into the uncanny valley. And this is actually real people, real movements, but actually real-time rendering. We've seen increasingly high-quality avatars. Synthesia does some great ones. The problem is they're still twice as long as real time for any given piece of video. So what does that give us? A couple of years of accelerating? You can do it. It's a cost thing, right? So the question is, how much do you want to pay? And maybe Suck paid a lot to get this done and show off Meta and try and drive his wealth and stock price up. But it was very interesting to see that they wanted to demonstrate real-time rendering here on this podcast. And this was in September. So it's coming soon. Now, it doesn't mean it has to be a real person, although what that other image there demonstrates is it's rendering on top of a scan of Zuck. Back to this slide then, red and blue put together. Well, we did some estimates. We think there's about $13 trillion cost a year in having those conversations, which is a fairly big prize. So do we think this is coming? It's about now, isn't it? So the big opportunity. We've noticed that there are some impediments people have in seeing what the opportunity is. One of them is the Kruger effect, and it's not just for presidents. People tend to overestimate the intelligence they're applying to things, their own intelligence, and that very often happens when they're being paid for it. Right? A special case of that is academics, and they live in a rarefied environment. So if it's something being reviewed by academics, they have a very high standard of intelligence that they look for. I can tell you, I've had more interesting conversations with the AI, conversational, than I hear on the bus in the morning. I hear all sorts of banality there. It's not hard to get beyond most of those conversations you hear out there in the wild. There's also a sort of wishful disbelief. So we've got we've been the apex intelligence on this planet, and it's really quite hard to look at this and go, is it going to take over? Are we not going to be the smartest things around? We also kind of seem to have this perfection delusion where we have a higher standard for the AI than the people that are doing the job. Very often, they're not even measuring it. And we say the AI should be doing this perfectly. And we've got used to computers being reliable and delivering the same thing every time because this is emulating a brain. This model is emulating an actual brain. So we kind of should expect it not to be perfect. But we deal with that as humans because we're not perfect, are we? I know I'm not. So we conjured up this idea of AI equity, which is maybe we should hold humans to the same standard as AIs. Fun, wouldn't it? And the other thing is actually the AI's language models are learning us, right? So they're going out there and learning from human-created content and learning human-created responses. And there's an awful lot of really nasty stuff out there that it's processed. So if we want the AIs to be better, we probably need to be better ourselves. For examples. So, in conclusion, in summary, I took a very big picture about technology and change and so forth. And I think our main thing with Digital Acumen is to really understand the nature of the social change. You need to look carefully at the opportunities, affordances, constraints of the technologies that are under development and dig deeper into trying to understand them. And that's really been, why did I go into embeddings and vectors and what's an AI model and so forth? I wanted to move that to a slightly deeper level where we could distinguish between different types of AI and what they could do for us. Number two, conversations are everywhere. They're pervasive, they're powerful, they're important. and they're complex. And so we need tools that are able to flex with that complexity and work with it. And actually, it turns out AI is really pretty good at delivering that. So going through the process, I could have, in the first demo, forced it to go back to the beginning and said, I'd really rather prefer to do this with human design. Let's not use strengths. And we'd have gone straight back to, well, okay, that's an interesting idea, but I know how to use strengths. Can we carry on? We'd moved back in the conversation and carried back forward from there. Conversational AI is not just about deploying an LLM chatbot, although some people seem to think that it is. They don't get you far. Content creation, question answering, but not a real conversation. The conversational AI tools that are going to come up will complement the other tools that we have for contact. Yes, the chatbots, the rule-based chatbots, the telephone systems, service desks, and so forth. They won't come in and eliminate them straight away. We'll use them first to try to displace some cost and try and improve their capability as we go along. But the age of conversational AI, it's not now, it is imminent. And we probably need to get used to that and start paying attention towards what is possible and where it can be applied. And so finally, before questions, is if you'd like to explore it further, then please contact us. We'd be delighted to hear from you. I'm going to skip the second last slide. Oh, no, not. It was a kind of little afterthought, but NVIDIA makes GPUs and supercomputers for data processing centers. And is that yesterday? 14th of February. Replaced Alphabet, and it's Google. That's the third most valuable company in the world. This is a computer hardware manufacturer. That tells us something because it's their hardware that's driving an awful lot of LLMs and AI. Okay. We'd welcome contact. AI@ipseita.com. You will get a response from a real life human. I wire it into a conversational flow. Yes.
Yes, and initially it will not be a human response, and it will not be an AI response, but it'll be very simple and short, and we will promise to follow it up. So, questions?
Questions.
So this is more of a thought, and one of the reasons that I wanted to come tonight. So I work in e-commerce, and I used to manage a B2B website. We're only selling gifts and homeware, so it was quite low value stuff. But obviously B2B can be, huge. You might be selling huge components or like building supplies or like really high value stuff. And someone from an agency said to me like, "Oh, did you know that you can now get negotiation AI, like negotiate, tools?" And I was like, what? Why would you want a bot to do that? Like, and honestly, my mind was, I went very, very far the other way. I was like, I can't believe that's a thing. Like, how would anyone want to rely on AI for that? Everyone wants the personal touch, and to think that their negotiation has gone really well because they've done their bit really well and influenced another human, right? Who's like their peer or whatever. So yeah, it's fascinating seeing that slide where you were like, this is how,
Of course,
this is where it's going to go. Yeah, exactly. And all of that nuance about, I've spent, however long building a relationship with my sales guy, and now look, I've managed to get my 15% off or whatever. Yeah, so that's just one of the reasons that I wanted to come tonight. I think it's fascinating.
There was I send my negotiation agent to talk to your negotiation agent about the price that we won't agree on. So there was an example where I think it was still called Facebook at the time. So some few years ago, where they set their chatbots talking to each other, and they developed apparently their own language, and they decided at that point to turn them off because they didn't know what was going on.
Yeah.
So yeah, that's an interesting future, isn't it? Where AI conversation agents have conversations with other AI conversation agents, and I wonder what kinds of negotiations they would have. Very interesting. Thanks for the comment.
So Phil, when you talk about conversational AI, you're referring to verbal conversation as well as textual conversation?
I think it's it will become multi-domain, and I think it will become multi-channel or omni-channel. In fact, I would like to think that you would be able to have conversation with an AI agent that responded differently depending on the channel that you were using, but still with the same context and the continuance of your conversation. So their responses may be maybe not in text form, but in spoken form. And you might have a very different style of conversation with voice than you have through video, but you still feel like you were conversing with the same agent. Will that come? Not immediately, but it's there. What I would expect to happen.
I think it'll also depend on not just the technology as it becomes available and more cost effective to use, but also the circumstances in which you would ask the question. If you use a phone and talk to your phone basically for very simple things, that's not a conversation, it's an instruction or a transactional, as in the chatbots that Philip talked about. If you are, for example, in a learning situation and you are learning something vocational in a job situation, and you've studied something and had a conversation with some AI tutor in your learning situation, and then you're on the job when it becomes real and you have to follow that up. You will want both the channel to be different and the style of response to be different, but the shared memory to be pretty well the same.
I'm trying Gemini. It's
Mhm.
quite good, yeah.
Good question. We have some questions from participants online.
Yeah.
So if you would like to read them out.
Okay, yeah, in response, yes, I'm also trying Gemini. I think it's commensurate with GPT-4. Whereabouts?
I sometimes use Claude if you're from Anthropic, which is freely available in a sort of chat form. It's very good and very polite at when you tell it it's wrong, and to reconsider the answer it last gave you, and it will generally give something quite good. But this is a chain of thinking sort of approach by which you ask a question, you get the response, and you, with some knowledge, some prior knowledge, you say, I'm not sure if you're right about that. Can you justify it or something like that? The conversations are limited in that way, but they can be fulfilling because they're actually prompting you as a user to think some more. And I think this perception of reasoning is often the effect it has on you as a user, whether it's confabulation or whether it's just slightly off or whether it's spot on, and it takes you to another place, as a conversation with a stranger would have.
Yeah.
Sorry, Mark, how do you spell that, Claude?
CLAUDE.
Okay, so we got a question here from Professor Dr. Xi Liu. I understand that one of the most effective training methods for LLM foundation models is supervised fine-tuning. However, you've classified LLMs under unsupervised learning. I'd appreciate it if you could elaborate further on your perspective regarding how LLMs are trained. Specifically, I'm interested in understanding the distinction between supervised and unsupervised aspects during the supervised fine-tuning process. I think what we've got here is a classification issue. So the training process for LLMs is sometimes called semi-supervised learning, or used to be called unsupervised. I think that when you fine-tune them, you give them couplets of prompt and response you want. In fact, the OpenAI term, I think, is reinforcement learning with human in the loop. So what they're effectively doing is saying, we're giving you a couple of responses, please choose the favorite one out of that, and giving the model feedback based on which one did you like, and then using that as further examples of prompt and responses that the LLM can learn. Sorry, I've lost that. I think, yes, in a way it's supervised because these are hand selected, and supervised learning, general classification regression sense, requires labeled data. So yes, I can see we're using blends of techniques to get the results. I think that's really all I can say without having been on the inside at the LLM training companies. Second question from online. Oh gosh, another one from Prof. Liu. Second question from online. An illustration of the differences between episodic memory and semantic memory is that you often know something without being able to recall when or where you learned it. Has your platform noticed anything like that? Well, I've not really asked it how it's learned things
No,
or when it learned.
If it's about our platform, it becomes a design decision for a conversation design, how much you want it to be remembered. If you had a conversation, you know, stretching over months, or as we come to these events and we see somebody that we see occasionally and can pick up from where we left off, if we each had perfect memory of the conversation, it would at least be strange. Okay, we don't work like that. Plus our life contexts will have changed, never mind the business context that might have been the subject of the conversation. So a failing memory might actually be, you know, quite useful in that regard. But you could program into our platform, you could have a module in that conversation design, which actually remembers absolutely everything. And if something emerges in that conversation because of the interactions and the AI models that are in the background supporting that, that could be recorded in principle. Not sure if I'd suggest it's a good thing.
Interesting comment that raises an important point, again, from Professor Liu. Your graph-based RAG development is impressive. Thank you very much. I've created a chatbot using Llama based on retrieval augmented generation techniques, which provides autonomously continues conversations and provides citations from a given database. Interesting use case. While it effectively prevents hallucinations, the drawback is its slower response time. And indeed, that's the important point, is we have intentionally neglected the lag time, the response time in our prototyping. We expect it to get faster, but it doesn't tell us what can and can't be done just because it comes at us slowly. So, you know, our decision was, we're not going to worry about that right now. We're going to think more in terms of conversations that take place on a chronic basis. And so an immediate response may not be necessary. But clearly, if you're interacting in real time and it's event-based, you're duplex conversation going on where people might talk over each other, or the bot might talk over you, you might talk over the bot. Gosh, when a bot starts interrupting me, that'll be a day.
Having said that, that phone completely lit up when you were doing the demo, because I'm on the same channel. So the conversation that Philip was having with the LLMs, I was able to see and could have taken part in as well, as it happens. Again, there's some, this is the interaction between sort of UI ideas and UX indeed, and these conversational AIs. I think it's going to keep people busy for a very long time, particularly as new affordances are being sort of uncovered. People find new ways of using.
Raymond's question, how to embed high quality decision making in an AI? How is the decision quality to be defined and tested? How do we understand stability of the decisions? Very good questions. So when I refer to decision quality, there is if you go to Wikipedia, you can find chapter and verse on decision quality. And there are criteria that you apply to understanding, but they're all focused actually on a commitment to action. Is that decision strong enough that I'm going to act on the decision? And so the decision quality was not about the conversational AI making a decision. It was the person that was interacting with being ready, willing, and able to actually pursue the decision they made. No, I might have crossed there, but even so, those questions are interesting, and I can happily say I don't know the answer.
Well, we have carried out some experiments, if you like, in this area. One of the setups I had was I asked my interlocutor basically to constrain the conversation to a specific set of topics and not allow me to go off topic. And it wouldn't allow me to go off topic. It simply wouldn't. And I even asked, when I asked something that was tangential, and in my mind, I could connect. So I asked, for example, it was about higher education and London universities. And I asked a question about sightseeing in London, and it would not allow me to pursue that. So you can oblige, you can design a conversation, which is rather harsh. We actually learned a lot from a company we were working with in the States a couple of years ago. One that we demonstrated our early work on in this area too. And we got permission to take a book, as we would now call it, a RAG, to fine tune the responses according to the tone of that book. Guess what? That book had been written by an ex-military man who had a very, let's say, authoritative way of coaching people. And that tone came across. Some interesting anecdotes out of the book came across as well, which we had to try and filter out. But I think these are good questions, and it's why we want people to think about conversations and not chat. They're very, very powerful, and they're usually the prelude to some action.
Yeah, I just had a question about the knowledge graphs. So if you're creating them based on company data and then prompting the model, how do you stop data leaks, essentially?
Firstly, specifically, if it was data such as systems of record and CRM systems or ERP systems or whatever, I probably wouldn't use knowledge graph. I'd probably use the native querying. And with that, yeah, there's a piece of engineering that's got to be done to make sure that the data that you provide to the LLM is compliant with your policies. So haven't got access to those systems right now, haven't done the engineering, but no, it's there. I can point you towards MicroStrategy that has an approach to use that for they've got a natural language querying tool that basically says, okay, that's the question. I'll write a query. Yeah, that query takes place inside the veil, and therefore I only have the permissions that I've got. I get that back out. I then I add that to the prompt. I can then provide a natural language response to it or a graph or a so it's solved. It's solved.
The questioner who mentioned Llama LLM earlier, you find that used an awful lot in on-premises secure servers, basically contributing to a richer system. So it's becoming like an in-house guru or oracle for the knowledge base that the company wants to keep inside for that conversation. You'll find some examples of that on YouTube, for example.
So an example of a knowledge base I might want to construct is perhaps an HR manual, HR policies.
Sure.
So, using the rules of real tennis is just a demo thing, but the other area that we've been looking at, we do quite a lot of work in the L&D community. So we've been talking about when AI tutors, and of course, what is distinct? If you've got an engineering school, part of the university, mechanical engineering, Birmingham, what makes your department of mechanical engineering different from any other department of mechanical engineering in the country in an era where the tuition is being done by an AI tutor? Well, it could be about the specialist knowledge that the people in your faculty have because of the research they've been doing. So you need to build and maintain a knowledge base that the AI tutor can then refer to develop the students. So we started sort of looking into this, okay, but you need to be able to maintain that, you need to be able to validate it, and you need to be able to ingest lots of academic papers, and you need to be able to ingest textbooks, PCs and so forth to actually get something that's reliable, but also differentiates your institution.
Is that kind of like doing a PhD?
That's an really interesting.
So much resources from so many places, then you finally hone in on the
Yeah, yeah.
question that you.
I used to say to my PhD students, go and explore the galaxy, but don't forget to come home.
Right.
That the same point is, I think that's a really interesting point, because in many respects, somebody who's a PhD candidate is an apprentice academic. Okay, so it's going through the traditional processes as much as the knowledge that they hope to uncover that gives them the right to have the title of doctor. That's great, but how does it change in this new world that we're in? I've not really thought about that. As I said earlier, I'm emeritus, which means I can use the old school stuff, but it's tricky. But it's going to be addressed. Content production in the L&D area that Philip just mentioned is enormous at the moment. And they adopted it really fast, but a lot of people, particularly independents, are left a bit behind.
So you're using Neo4j to represent knowledge, a collection of facts, of interconnected facts. Now, facts in the real world change over time. Have you managed to represent that? So for example, if, let's say, the product offerings of company XYZ, product A had certain features at point 1 in time. It has different features at point 2 in time. Could I in theory ask it, well, point 1 in time, what could product A do for me? And what is different from point 2 in time?
So we've got a spectrum of degrees of how structured the data is and the tools that you might then use to store it and maintain it. And sometimes I sort of look at this and say, well, actually kind of that's conversation designer's problem, is to figure that out, is that which is the most appropriate database to use for this task. Is it a vector store? Is it a knowledge graph? Do I want a document thing? So actually we're running Neo4j, we run Mongo, 2 instances of Mongo to do that demo. And it's just a question of courses for courses, what do we want to do? And what we're trying to do is take this relatively unstructured data, all the document is structured, and say, actually, can we get the LLM to actually respond correctly to what it chases in real tennis? And other questions around it seem like a fun demonstration. But if they were then to change the rules, well, that particular document had revised in 2012 on the cover and captured that piece of information, and maybe the 2024 rules use a different shape for and brackets that aren't asymmetrical.
If I can get him off real, your problem is a classic knowledge management problem. Yes. So one of the things that these kind of systems, the kind of way we've envisaged things anyway, is to take your colleague in front of you who talked about B2B sales, is if you had access to the database about how those sales had transpired, whether they've been repeat sales, you know, what discounts, etc., all the knowledge that is captured by those transactions, then that could change the way that that information is actually perceived, because it may actually be a perception rather than a physical change in some way to the product or service that's being offered. So, you know, it's the complexity of human life can maybe be captured here. And the richness, complexity sounds like a problem.
If it's a physical product as well, they should have like release or like a different SKU or a different
Version.
Yeah, like they should be tracking their own
We
version.
can't hear it up.
Oh, sorry. Yeah, if it's a physical product,
Yeah.
I'm talking about, like if it's a component or something,
Yeah.
that should have different version IDs anyway, right? Or different SKU ID.
And the data sheet should, you know, for that product should actually be fed into the mix. But then you need all kinds of other systems of automation that are probably at the minute and for a long time will be human-based, and there will be some problems. I didn't say at the beginning, there were 2 technologies when we started the company, and actually I won't go into it now, but maybe later. The company got its name from our interest in an application that needed both blockchain and AI, pre-LLM AI. And if you had blockchain, for example, in the mix, so the stuff was immutable and accessible, then you begin to develop sort of further RAG resources. Somebody here at the front had a question.
Yeah, thank you very much, and well done for your research. As regards exploring the galaxy, going back to the old age and using the new technology, I think we need both for reality's sake.
Yes, but there is my but comes from an observation over many decades that unless you commit to doing something for real, you dodge the difficult questions. If you dodge the difficult questions, you know, we didn't talk about security or cybersecurity here, but that's all a massive part of what's in the background here.
Yes.
And it relates back to the question about leakage of data, for example. So there's a lot still to be done here.
Thank you.
David, are we out of questions?
Yeah, we're on to questions.
Thank you.
Alan, I think we're done unless anybody else has got a last one. I think they realize the pizza has arrived.
Fantastic. Well, thank you both. That was, well, to my mind, excellent. But did you understand it? Who is working in AI at the moment? And the answer here is roughly a quarter of our audience. Okay. Now, let me put something to you. We talk now about somebody having a brain the size of a planet. Is that going to be adequate in the future? Are we going to be talking about somebody having a brain plus an AI bot or database the size of a planet? Which leads me to say, and if they do have one the size of our planet, boy, oh boy, what about all those imperfections and false thinking and so on? Who is working in ethics? Yeah, is anyone?
I'm researching on it.
Okay.
Researching, yeah.
Half a kitty, and that's all. Yeah, this is going to be tomorrow's problem. How do we address them? So, lots of food for thought. And on that note, I'd just like to say that if you'd like to go next door, your exam sheets are waiting there. Only when you pass the exam will you be given food. Hold on a sec, hold on. Oh no, that step's been removed. Please go next door and have some food and drink. Thank you very much.